So we're going to go over compound inequalities today. What do you think of when you think of the word compound? More than one, right? So compound definitely means that I'm going to have more than one value that I'm comparing to my possible solutions or my variables. Okay? So here's some important information that you need to know. There are two kinds of compound inequalities. Your and problems or statements and your or statements. Your and statements have solutions that are connected, and you're going to see what I'm talking about in just a minute. Your or statements have solutions that are actually going to extend in opposite directions. And again, that's going to make more sense in a minute. But I'm going to ask you, is this an and statement or an or statement? And then you would respond with one of those answers, okay? So you're going to hear me say that throughout the lesson today. Okay, so let's move on to example 1. In example 1, we have both kinds of statements here from an inequality, okay? And I need to explain what you're actually looking at here. All right, in the first statement, remember we need to read the variable first. That x is going to be greater than greater than 3 and less than or equal to 10. So what we see happening, guys, with a compound inequality is we're actually setting boundaries on either sides of the solution. It's not that it's going to go on to infinity. There are only a couple numbers that are greater than 3 but less than or equal to 10. Give me a number that would be a solution here. Greater than 3 but also less than or equal to 10. Maya? 4. Give me another one, Jace. 5. Ethan? 7. 9. 8. Okay, so we're in that range, right? 4, 5, 6, 7, 8, 9. What about 10? Would 10 still be true? Yes, because it can be equal to. Okay? So I need to show this on a graph. We're going to make this real simple. We don't have to write all the numbers in between. We're going to plot each value on each end of this compound inequality. Meaning on the low end we have a 3 and on the high end we have a 10. This is what we call an and statement because our solutions are connected. It can be greater than 3 but less than 10. So we're just going to kind of highlight here to show that the solutions can be in between. But now I need an open dot or a closed dot. How do you know which one's going to be which? You need to look at the inequality symbol. If it's greater than 3, that means it's an open dot on the 3. If it's less than or equal to 10, that means it's a closed dot on the 10. And then all the solutions can be between those values. Okay? But they don't extend beyond those values. So there's no arrows that go on the other ends. Those are the only solutions. See what I'm doing there? I'm saying these are the only solutions to that compound inequality. All right, so you can put numbers on either side to show that the numbers are continuing to decrease and increase, and that would be fine as well. I actually just touched base with Ms. Johnson, and this is how she does it, just with those numbers on either side, and I'm fine with that too. Okay, so that makes it a little easier. Now, on the next statement, I see a pretty obvious word there, right? Or. Or separates now two statements from each other. That an acceptable solution could be, how do I read that? Greater than 4, but also less than -2. So I need to show this again on a number line. This is what I call graphing the solution. And again, I need to plot my numbers. Okay, so down here at -2 and up here at 4. Okay, and again, we can write a couple other numbers on the graph just to kind of show how the values are trending. And would it be an open dot or a closed dot on the 4? An open dot, and which way is my arrow going? To the right. Okay, And then what about how could I graph x is less than -2? Open or closed dot? Open. And which way does my arrow go? To the left. So remember what we said about or statements at the beginning. What did I say about their solutions? They're split. They go in opposite directions. So here I have a gap. I have a gap here between -2 and 4. Those numbers are not solutions to this inequality. Give me a number that would fall into that range that would not be a solution. 1. 0. -1, 2. Okay, but any number less than -2 or greater than 4 would be true. Okay, that's all I'm showing here by the graph. Okay, so next slide. You have 3 problems like this on your homework tonight, where you're going to write an inequality from a graph. So I'm going to give you a graph. All right, and here is your graph. I went ahead and put all the numbers on the graph. Again, it's not necessarily something you have to do. Okay, so what I want you to do now is I want you to write the inequality that's represented by this graph. Okay, so x would go in the middle. Okay, and you have to decide what numbers would go high and low around the x, and if it would be less than, or if it would have the equal to. What do you think? What number would go to the left of x? -3, because it's the lesser of the two values. And how does x compare? X has to be what compared to -3? No. X has to be greater than. Now, then it is true that -3 is less than or equal to that value, okay? But what we're saying is all my solutions here are going to be greater than -3, okay? That's what we're saying there. All right, so what has to be true about 2 then? All my solutions have to be what compared to 2? Less than. Now, do I need the equal to bar? Nope. Okay, so less than 2, and that's it. Okay, so now, what do you think, what kind of statement do you think I'm going to give you on the next one? Okay, let me ask you this. What kind of statement was on the first one? An and statement. How do I know that? Because my solutions are connected. Okay, so what kind of statement do you think you're going to see next? An or statement. So what's going to be true about them? They're going to be split. They're going to be separate. All right, which means I need an inequality for this one, and I need an inequality for this one, and then they will be connected by the word or. Because either one, either value or range of values could be a solution to this compound inequality. Because this statement is split, guys, watch this. Because it is a split statement, it's or, I'm going to write 2 different inequalities. Okay, on the first one, it's x is what? How does x compare to 0? Less than or equal to 0. Now I'm going to write my other inequality, or x is what? Greater than 4. Okay, so I have 2 separate inequality statements connected by the word or. So there are only a few numbers that are actually not a solution here. Give me a number that's not a solution. There's only a couple numbers that fall in this gap. 1, 2, 3, and 4. Okay, and that's it. All right, are you starting to see the difference between compound with the and with the or? And my solutions are connected. Okay, there's boundaries. With or, they're going to be split in opposite directions. All right, so your last 2 problems on your homework tonight deal with writing a sentence or a compound inequality from a sentence and graphing the solution. Okay, so it says a number D is more than 0 and less than 10. Would this be an and statement or an or statement? Is more than 0 and less than 10. It's an and statement. Okay, so here's D in the middle. Okay, which number is less or a lower value, 0 or 10? 0. So 0 goes on the left and 10 goes on the right. So how does D need to compare to 0? What did it say? It's what? More than 0. So it needs to be open towards the D to show that it's more than 0 and what compared to 10? Less than 10. And now I come over here and I graph that solution, okay? More than 0 and less than 10. Go ahead and graph that compound inequality. It's going to be a 0 on one end, and it's going to be a 10 on the other end. Oops. A 10 on the other end. And open or close dot on 0. Open, and open or close dot on 10. Open, and then you just fill in the space in between. And what I'm saying by filling in the space in between is any solution greater than 0 or less than 10 would make the inequality true. Give me a number. Give me a number that falls in that range. 1, 4, 3, anything between 1 through 9. So that's what I'm showing. It can't go past the 10. That does not make the statement true. Okay? All right. Well, let's look at the next one. A number A is fewer than -6 or no less than -3. You see that key word there, the or? Okay, so right there, it's going to split it. It's going to split the statement. This is an or statement where as soon as I see that, I know that A is going to be written in two separate inequalities. You can go ahead and write two A's. Okay? And how would I write that A is fewer than -6? How would I write that? -6, and then I have my or statement, or A is, how would I write this one? Yeah, because if I said you could be no less than 16 to drive, 16 years old to drive, you could still be 16. So no less than -3 means you can still be a -3, okay, and be a solution. All right, so there's my compound inequality. And now I need you to graph it. Go ahead and graph it. So still on one line, okay, so I've got one line here. What number goes on the left side? -6, because that one's less. What number goes on the right side? -3. Okay. Open or close dot on -6? Open. And which way does your arrow go? To the left, showing that any solution less than -6 would make it true. Okay? Or open or close dot on -3. Yep, an arrow going which way? Right. To the right. So any solution greater than or equal to -3 would also be true. So give me some solutions that are not true. -5, -4, and -6. Those are the only three numbers in the whole universe that would not make that inequality true. Okay? How do we do, guys? All right, so you have 5 problems for homework tonight, numbers 1 through 5 on your 2.5 worksheet. All right, you guys can go ahead and get started on those, and we will do the second half of this between tomorrow and Thursday.